Quick, what's news in Visual Studio and .NET? So had a new release of VS Code come out. 164.1 is the latest version. I think that minor update might have come out just overnight. Some nice new features. I saw this new side panel feature is interesting, where you can have some extra stuff over on the right hand side in VS Code. We've also got being able to prioritize whole word searches. We've got some audio cues. Just friendly reminder, people joining, just make sure you're muted in the chat. That would be appreciated. We've also got some enhancements to Terminal, Notebook UI, if anyone's using Notebook. Be interested to hear about that. And yeah, the VS Code for the web, is it vscode.dev from memory? Yeah, interesting as well. Visual Studio 2019, there's a minor update for that came out overnight, which has had some security and bug fixes. So that's a relatively stable product. I think most of the fixes are around C++, so unless sort of for .NET developers, probably not as interesting. But yeah, nice to keep up to date with that one. For Visual Studio 2022, the GA release also was an update. There was some security and bug fixes in that. Also some improvements to the installer, which was nice to see. The 2022 preview, there was an update for that came out at the start of this month. So there's some new features coming in the next release of 2022. If you want to try them out before the release, then you do that through the preview release. And .NET also had some updates. So .NET 6 and .NET 5 had some minor updates just to fix a security issue that had been reported. Just a reminder that .NET 5 is out of support in May. So only a few more months and .NET 5 won't be supported anymore, so no more releases. And .NET 3.1 is an LTS release, but that also will be out of support by the end of the year. So if you're wanting to make sure your applications are able to take sort of bug fixes and security fixes, then moving to .NET 6 is probably a good plan. Quick plug for 30 Days to Learn. If you're interested in doing a Microsoft certification, then going through one of these learning challenges on the Microsoft Learn site is an easy way to get a 50% discount on doing a Microsoft exam. So next month, pretty excited to have Kendra Havens. She's a program manager with Microsoft in Redmond. Simon and I spoke to her this morning, just recording a promo clip for next month. Yeah, pretty excited. We're going to have another virtual meeting next month, and this will be a lunchtime meeting just because Kendra and the time zone difference was just a bit kinder to her, not to make her stay up ridiculously late. So it'll be lunchtime. So if you're working with your team, maybe set aside this time as a bit of a lunchtime lunch and learn sort of session maybe. She's going to be talking about Visual Studio 2022 and sort of C#, .NET 6, and who knows, there might be some new announcements she might be able to talk about by the time we come around in a month's time as well. So looking forward to that. A very fantastic presenter and really gets you excited and enthusiastic for the product. So looking forward to that. If you love catching up with developers more than just once a month, then do be involved with the Heaps Good Dev Slack. So there's a QR code there. If you could scan your screen on your phone or something, or post in the chat if you'd like to say hello. Yeah, great place to catch up with other developers and a lot of great conversations, particularly focused around South Australia and Adelaide software developers, not just .NET, all platforms, and all kinds of great discussions happening there. Our YouTube channel, just a plug for that again, and yeah, hopefully we'll get the recording for tonight's talk up there soon, and yeah, appreciate some extra subscribers on that would be great. And a quick plug for the new Breakpoint live program that I was pleased to be a part of late last year with Melissa, talking about .NET 6 and Visual Studio 2022. That's being published on Twitter. So if you want to search up for some of the the newer editions of that, then jump onto Twitter and search for Microsoft Dev ANZ. And that's it from me. The dates for the rest of the year for our group are up on our GitHub account, but the second Wednesday of the month, we're always looking for new speakers. Love to hear from you if you'd be interested in presenting, just like our presenters are this evening. Okay. All right. Yes, we're also on Facebook and Twitter. Special thanks to our sponsors. First of all, Simon and Christine, looking very smart there in their slide. I suspect that photo might have been taken before they had to do homeschooling, because it's a hard job doing that. So, but yes, great people to talk to if you're looking for some developers to join your team, or if you're a developer who wants to change where they're working, have a chat to Simon and Christine. Really great people to talk to. And also to Tap2, and we're going to hear a bit more about Tap2 very shortly. And in fact, some of these photos here might look a little bit familiar if you're looking at some of the people joining the talk tonight. So we do thank Tap2 for sponsoring the group and supporting us, and we're really pleased to have some of their people speaking to us tonight as well. Hand over to our speakers. Thank you, Huluka, Ryan and Esayas.
Thank you very much, David. Yeah, a huge thanks for inviting us to come and speak to the group tonight. It's great to be able to give back what we know and what we do. So and look forward to you guys doing future sessions. I'm just going to share our slide deck. So just bear with me while that comes up. Alrighty. So tonight we're going to talk about scalability architectures in commercial software. And just before we get into the meat of the conversation, I thought that I'd take a little bit of time to introduce introduce ourselves and the business. So Ryan.
Yeah. Hi all. For those who don't know me, I'm Ryan. I'm a software and solution developer at Tap2, and I've been around the .NET group for a little while, so I'm seeing a lot of familiar names.
Hi, this is Esayas. I'm new to the city and even the .NET group as well. So working with Tap2, full stack development. Thank you. Nice to meet you.
And my name is Huluka Gnezda. I'm a director of Tap2 and a digital strategy and architecture specialist. Okay, so then about our teams. So Tap2 is our primary business, and we're a boutique Adelaide-based digital expertise and software company. Basically, we're a bunch of digital experts that have a great time with tech and a great time with our customers, and we love producing signature outcomes, things that are a little bit quirky and different. Beside that, though, we've got a social enterprise that we're really proud of. So over the last 6 or 7 years, we've built up Headful of Heart. It's a cost recovery social enterprise that tries to get young professionals activated in the community, participating, learning, and becoming the next generation of our spokespeople. And it's great to actually notice a few names of people that have worked with us over the years and gone through elements of that Headful of Heart program. So thank you so much for coming tonight. For those people, you know who you are. So what I want to do is just start off with a little bit of background for the talk. I just want to introduce the context of what we're going to speak about and how it works. And what we'll do is we'll come back to that towards the end of the talk. So we're currently building a software as a service platform for a customer of ours. They have asked us to go with them on the next 2 or 3 years of their journey to help them take some software to market and then to gradually help them build out their own team, which will gradually replace members of our team. So we're under NDA, so I can't actually explain to you tonight what it actually does. But what I can say is that it's relevant to businesses and individuals alike. And in some way, it's responsible for tracking aspects of humans and business, and then optimizing personal and business outcomes collaboratively through that process. The key thing is, though, that the service that this platform will provide is common around the world. And so what we've received as part of the initial requirement stack was that this eventually has to be designed for global SaaS scale. So because we're dealing with human aspects and because global scale is relevant, what this really starts to say to us is a few things. Security is super important, like it always is, and like it always should be, but because we actually have subtle pieces of data about human beings, it's doubly so. Scalability is important, and the ability to share data sets between groups of people. Data integrity, because there's a lot of mathematical logic that gets applied to generate statistics and the like. And data sovereignty, because this is about businesses and the people in them. What this really says is that customers need to be able to maintain their data in the region of their business and under the legal jurisdictions of that region. So what we need is a software architecture that can deliver commercial SaaS outcomes. We need to be able to implement in a light and malleable way while we're in the startup phase. And this is super important. If we go and overinvest in architecture up front, then we don't actually get to deliver on the feature sets that will prove that we should be in the market. But likewise, if we don't spend enough on architecture up front, then what we'll do is we'll eventually accumulate technical debt. So what we're trying to do is have our cake and eat it too. And what we're going to show you tonight is how we're trying to achieve that. Now, what that then means is that the architecture that we build needs to be able to be deployable on a micro scale and keep costs down, but then gradually scale as demand increases, scaling servers up, out, and across along with our code base, which is actually a really fascinating thing to try and achieve, have an architecture that works at the very, very micro and the very, very macro. Now, we also, as part of our business, value AppSec really strongly. I think we like to think of ourselves as one of the best local exponents of AppSec in the market, and it's nice to see some of our AppSec team in the audience tonight as well. So thank you. But essentially, this is all about the principles of shift left. So shift left, I'd encourage you to go and have a bit of a read up on it to do with AppSec. Really what we're saying is that rather than pen testing at the end of a software cycle or periodically through a software cycle, that actually you want to ingrain security principles into the DNA of the software that you write. We also, as I mentioned earlier, need to support data sovereignty and localization of data. And all of this stuff all adds together into this large ecosystem that says we really need to do this well and do this right to avoid technical debt. So with that, I want to have a throw out to one of the great exponents of our industry that we need to go well. And so in the words of Robert Martin, there's no trade-off between quality and speed. There never has been. Low quality means low speed. So the only way to go fast is to go well. What that means is that we need to think about the right things at the right times, do them in the right way without overcooking things. And it's a really, really difficult thing to do well in software. Now, who's Robert Martin? Hopefully a few of you in the group know who he is, but I just thought I'd just quickly have a throw out. Does anyone know why Bob's famous? There's a few thumbs going up. So if you're not familiar with the exploits of Robert, I encourage you to look him up online. He's famous for being one of the 17 creators of Agile, and he's been one of the great exponents of how to write great code. So encourage you to go look. At the end of the slide deck, we'll have some links that help you find him. So I now want to make a call out to my product management colleagues, and I also want to give a bit of a plug to Good Product, the product management user group, who are kind of our local Adelaide neighbours. So the concepts that we're talking through tonight are going to be very technical, but actually they have their trappings in product management. And so I want to start the story here. So it's really tempting when you build a product team and you're being asked to build an MVP to say, let's worry about these really epic problems later when we're making money. Let's actually get feature out and push that through at very high velocity. And so Robert Martin speaks to that part of it, but the question is, what actually do we need to focus on? So it's really easy to say with global scale, let's worry about that when we scale globally. It's something that we can defer. Because it's not a functional feature, we won't prioritize it in our product pipeline because it's not something that our customers can really easily prioritize. But what I'd argue is that if you're actually managing product vision statements, product principles, then you'll actually see, if you are looking at a global SaaS platform and that's peppered through your vision, then global scale will be subtly peppered through all of the aspects of that product vision. And so actually it is something that has to be thought about as part of the build. And what we're going to show you is that some of these things are actually way, way easier to include and embed in a team, both in development and DevOps and DevSecOps for that matter, on day one. But if you wait to a day 1000, it's really hard to refactor and introduce this into your code base. It's even harder then to do it really well into your operational practices because your team's not used to it, not ready for it, and it's a fundamental mindset shift. Whereas if the developers have actually participated in the actual construction of that and they know the DNA of your architecture, then actually running that in a DevOps or a DevSecOps mindset is way, way easier. And all of this stuff matters as you start scaling and you start getting your customers and you're trying to worry about keeping them happy. So how do we go about that approach? When someone comes to us and says, we would love to build a hyperscale software platform, but we needed to start small, we begin at the beginning. So as we're laying down solution architecture, what we do is we start with a persistent set of guiding principles, and then we grow and evolve a living set of specific decisions. Now, we use SharePoint Online for tracking those things. We've got a whole wiki architecture that we build around that lets us track all these decisions and things. I won't show you that tonight, but I do want to talk to you about the principles of how we get there. So you start off with the business objectives, usually a product vision. Then from there, we can identify principles that allow us to make decisions. And then from those principles, we can actually start making left-right type decisions. And then from that teaches us about the patterns that we want to implement. And then from the patterns, we can actually go to solution architecture detail, both in the code and on the in documentation. And then what we do is we cycle that continuously as we're learning, because software is a learning pursuit and product is a learning pursuit. So as we learn about the product, we're continually making decisions. The decisions change, but the guiding principles change very slowly. And so I'm just going to give you a quick example, and then I might just pause because I did see a couple of hands go up at one point. So we start with a product vision statement. Now, the way we build these is they're usually large one pages, at the home page of a wiki that has all of our content behind that, so that it's impossible for any member of the team to not see it. So we might have a statement that goes over several paragraphs, talks to different sections and things, but essentially it might say something like, our vision is to build and operate a globally available commercial SaaS offering that will do X, whatever X is. And so from that, what we can do is we can produce a decision guiding principle, which might say, as a product team, we want to build distinctive capabilities, things that are hard to buy, things that differentiate us in the market. And what we're going to do is we're going to buy common or standardized capabilities. And so now what we can do is we can apply that guidance to our decision making. And so we can then say, well, okay, we want to then procure PaaS technology X to deliver our identity and auth stack for this platform. And so what we can then do is we go out, we procure that. It's a standardized capability. Lets us spend more time building the software feature set. And then from there, that decision then lets us do things like, well, hey, we're going to use authorization code flow with Pixie as one of our patterns. And then we can build an entire solution architecture ecosystem code base all around that one thing. Now we have traceability from vision down to line of code. Super important for disciplined product over the long term. I love that. Don't ship shit. Thank you. Thank you very much. Great point. I couldn't agree more. All right. So, a few specific decisions relevant to our platform that we're building and this talk. So one of our decisions through those guiding principles has been that we're going to focus on PaaS hosting rather than IaaS hosting. IaaS hosting is awesome, love it, but we wanted to spend as much of our limited budget as we could building solution, and PaaS lets you go way further, way faster. And there's some pretty amazing stuff that's on the Azure platform around PaaS hosting. And yes, PaaS hosting can scale and can scale well. So we're using Azure predominantly for that core hosting, and then we're using some third-party PaaS services for things like identity, messaging, payment gateways, those type of things. Our front end is a single page application, Angular to be specific, but essentially at the end of the day, HTML, CSS, TypeScript. We've got a modular set of API stacks, so not one API, but a set of APIs, each doing a different part of the problem. That's built in .NET. It's RESTful architecture, things that you guys probably have seen a million times over. Our data storage is mixed because our data that we're managing is mixed. So the core of it is in SQL Azure. Then we have some elements that are hybrid, where we've got JSON structures within SQL. And then we've also got blob stores with a whole range of non-relational content. Each API stack then implements its scalability platform for its intended workload. And that's super important because what that says to us is that as we break our problem down, we can actually tune each part of our problem differently. And with that, I'm going to stop talking and I'm going to let my colleague Ryan take over, and he can start to talk to you about some of the specifics of these scalability platform patterns. Over to you, Ryan.
Thank you, Luca. So with that, we've been given a truckload of requirements and targets to try and meet. We need to be able to have data sovereignty in our patterns. We need to be able to scale globally. And so we need to architect this into our software. So what I'm going to do is I'm going to talk you through the three main types of scaling, from the easiest to the really tricky ones that we're implementing, and then talk you through a couple of the more interesting patterns that we're using for this. So the three main let me just take control. So the three main forms of scaling: scaling up, scaling out, and scaling across. In a nutshell, scaling up is just using a more powerful computer to run your codes. You're increasing the specs, increasing the RAM, etc. of the server that's running your code. Scaling out is you have more of these computers running your code in parallel, typically with a load balancer determining where each request will be directed. Scaling across is a little trickier. This is where you need to architect your code into modules that are small enough so that they're not going to be overwhelmed at the scale that you're going for, or can be deployed multiple times, yet still act as a cohesive system. So before we go into the nitty-gritties of each of these, we're just going to briefly introduce how we're hosting our system. As Luca mentioned, we're using Azure for a platform as a service host. We have a few third-party applications that we have to connect to for out-of-the-box capabilities that are buy rather than build. And in the actual host, we have our front end hosted in storage container blob stores. And we have our APIs hosted in Azure App Service Plans as app services. Going down another layer, we have our data hosted. So we have block data, such as media files and the like, hosted in storage accounts, again, blobs. We have queues for coordinating our jobbing engine. And of course, we have everyone's favorite SQL Azure for our relational and transactional data. So the first form of scaling up, getting the bigger, more powerful computers to run your codes. In a nutshell, this is easy. This is the simplest way to scale any codes. You literally just increase power and get a bigger computer. You can scale any software application this way just by running it on better spec machines. However, because it's just running on a better spec machine, this very quickly hits a performance ceiling. After a certain point, you hit diminishing returns, and after a certain point beyond that, you simply can't go any higher. The technology is just not there to run faster than a certain point. For us and anyone else hosting in a cloud service environment, this will be handled by your hosting platform. So in our instance, this is handled in our storage accounts as they scale out and up transparently to us, as well as in our app service plans, where we can increase the performance tier of the servers they're running on, and in our SQL Elastic Pool, where we can also increase the performance tier of our SQL servers. There's not really much more to say on scaling up. It's a fairly simple form. The next one we want to talk to is scaling out. This is, you have more computers running the code. Quantity over quality. So this is also a fairly easy way to scale your code. You literally can just run multiple instances of your code in parallel, and you'll often have some sort of load balancing thing directing requests to an instance of it. The reason I say this is fairly easy is that the only real requirement for being able to use scaling out in your code, in your servers, is that your application is stateless. If your application has to manage state between different requests coming in, there's a chance that any given request will go to a different server And so the managing a state stops working. But managing state's not really that necessary anymore. If you need to manage state for a session, you can use tools like cookies or any other header that you want to make up for that matter. Or you can do the route we went, which is to have every API endpoint being standalone using a RESTful pattern. So a object get will get an object with that, with the given ID. Permissions depending, of course. Again, this has a performance ceiling, but it is much higher than scaling up, as you can much more easily add more computers to run your code than you can making a more powerful one. And is also handled by, for us, Azure, but for your SaaS platform, whichever one you are using will handle some form of scaling out. Within our app, this looks very similar to our scaling up. Storage accounts, again, transparently do scaling up and scaling out for us without us having to do anything. App service plans have a slider to let us determine how many running instances of our application we want. And SQL Azure can let us run multiple instances of an SQL server in order to be able to service more requests against the database. So, the fun one. This is where it starts to get interesting and a little trickier. Scaling across is where you really start having to build your system around it. Essentially, scaling across is determined by how you decompose your problem and your software solution into different modules that perform different capabilities or can be replicated to perform the same capability in different locations. What having our software in smaller modules lets us do is it lets us have our application and our data spread out geographically, or at the very least, logically. This does need to be designed into your solution architecture in almost all situations for this to be able to work at all. You can't take any arbitrary web app, clone it across to another region, and pretend it works as a cohesive system. The system needs to be able to work as one system across the globe, not one system in America and a completely different system in Australia. So for us, the way we're doing scaling across is by having our code deployed in multiple locations. And so what we can do with our code is we can deploy our resource groups in every region that we wish to support. And so to allow this to work, we've actually had to architect our data model and our app services to allow for us to have replicas of our code in different regions, yet the whole system to act as a cohesive whole. And that is where the architectural complexity comes in. So, how we're actually doing this. Let's talk to some of the patterns that we're using to implement scaling across in our system. When we're breaking it down, we identified two main types of data. The first is core data. This is the type of data that's common to most cloud systems. It's data about who's using your system. It's data that says what people have access to. It's data that says what their auth provider tokens should look like. And in our case, in particular, this might not always be the case, it defines the logical boundaries between our different parts of the data. In our particular case, we've identified that this data is actually high read, low write data. But it does need to be able to be accessed from anywhere in the globe with some speed. So the pattern we've chosen to implement this with is command query. The way command query essentially works is you have one region designated as commands. This is the region where any write requests must be sent to and will host our primary database. What you can do then is you can have a number of secondary regions. And with these secondary regions, you're going to have your code deployed again. So these are our resource groups redeployed in these secondary regions, as well as the database. There's a read replica of the database in the primary region. And so we're using SQL Azure GeoReplication for this. And what this will let us do is any request that comes in to any API, we can check, is this the command region? Is this request a write request? If it does not need write access, we can process that request locally. If the request requires write access, we have to redirect the request to the command region to process it, and then have that data be replicated across to our region. So what this lets us do is optimize for low write, but high read by having everything available to be read quickly in local regions, but still centralizing our data by having only one database as our primary database where all writing must be done. So we have a small demo of how we've actually implemented this in code. I'll just switch the share. All right, so here we have a very simple butchering of everyone's favorite weather forecast app. So we've made a weather forecast app with two endpoints, a get the forecast and set the forecast. Nothing revolutionary, nothing too complicated, but you'll notice these extra attributes on these endpoints. Get is a query endpoint, which means that it only requires read access. However, command is a command endpoint. Sorry, the set is a command endpoint, which means that it requires write access to the data. Also in our application, rather than trying to deploy a database for this demo, what I've done is I've simply made a static variable to simulate our data access layer. So we have our summary of it and our temperature. On top of this, we have I'll talk to this first, the app settings. So we have two app settings, and these need to be configured per region. One that simply says, is this the primary API? So that says, is this command? And we also have a URL for where command's located. For this demonstration, I'm using port 7244. Don't worry, that number is not actually important. So what happens when a request comes in and it comes to a command endpoint or a query endpoint? We actually have a piece of middleware declared in our startup. There it is. The command query middleware. So what this piece of code does is, as our .NET MVC is processing a request coming in, this middleware is also triggered before it reaches our actual endpoints. It does some boilerplate stuff to make sure that the request isn't butchered if it's going to be passed through. Then it has to determine, is this request suitable for me to handle? So what this does is it retrieves data about the endpoint that it's reaching, either get weather forecast or set weather forecast in this case, and it attempts to get a piece of metadata, which is, does this endpoint have the command attribute attached to it? If the command attribute is not set, so that means it's not a command endpoint, which means it doesn't require write access, or this API instance is configured to be the primary API instance, we can continue with the request. So await next context just means continue down the middleware stack, and eventually it'll reach your controller and process your request as a perfectly normal .NET API. However, if this is not true, so if it is a command endpoint and this is not command that we're running in currently, so this is our secondary API, we have to redirect this request to where the primary API is located. So what we do is we create a new request message, then we clone our content into it. So we clone our body contents into the request, We clone our headers from the request coming to us into the new request that we're forwarding. We can generate the URL that we're supposed to send this to. And so this is where we use our configured primary URL base that says, okay, this is where command is actually located. And construct that URI, then forward this message across to the command API. This piece of code is a particularly nice piece of engineering that comes from my forebears before me and contractors. So I have to give a shout out to them. Thank you very much for writing this code for me. So what we do with the sending is we have a little bit of boilerplate to be able to handle things that we don't actually need to handle in these cases. Set a client handler, disallow redirects because we don't want this to get stuck in a loop, and then send the request. And then we do pretty much the reverse of what we just did to copy the responses into a new response object and return the response, and then send the response back to the client that made this request. So that's the core of this demonstration. Now, let's actually run it. So if I just switch this over, I have two pre-configured APIs, a command API and a query API. I'll go ahead and try and run both of those. We'll see that we have command API running on port 7244, and we have our query API running on port 5001. So if I go ahead and open up Postman now, we can request to get the weather from our endpoints. So if we do a get weather from our query endpoint, we'll see that there's log statements coming from our query endpoint saying that it's continuing with the request, and it's serving our request saying the temperature is around 0 degrees and summer is okay. And that's indeed what we get back in our response. We can also do the same thing for commands. And retrieve data from commands. Cool. So we can access both of our APIs. Great. But now we need to send some data. So we want to update the weather to say it's a bit warm. It's 25, it's warm. We can contact our command endpoint directly to make this happen. And so we send that, it hits command endpoint, it says this is the primary API, and continues with the request. And then if we go ahead and fetch this information from commands, we'll see that the command's data has been updated. It's now 25 degrees and warm. So now, if we send our request to a query endpoint in a secondary region, we say the temperature's 40 and it's scorching now. We can submit that. And what we see happen is it hits the query endpoint and the request actually gets redirected. Then command can handle it and set our forecast information. So what we then see is when we try and retrieve the weather information again, it's been updated in the command region. Now, there's one piece of the picture in the command query pattern that's not implemented in this demo because it's a little tricky to show in a good demo and requires you to have multiple databases synchronizing, well, in one direction at least, for our geo-replication. If I try and get the weather from query, it will still return the default 0 because the data has not actually been replicated from command to query region in this demonstration. But in a full deployment, you'll have some sort of technique like SQL geo-replication to move your data from command to query so that you can access the most current data from the query endpoints. And that's basically it for the command query demo. So I'll switch back to slides. So when I talked about our core data, I hinted that there's actually two classes of data in our system. We have our core data and we have our pattern that we're using to handle our core data. However, there's not many systems that can survive with only high read, low write data that aren't just basic broadcast. We have solution-specific data as well. In terms of generic cloud systems, this is the super secret sauce that makes your application so special. This is where you need to get creative. This is where you need to decide what patterns work best for you and your application, and look long and hard at what requirements you're actually trying to serve. So for our system, we had the requirements that we have a lot of highly transactional data. We needed to be able to keep really strong audit trails on our data. We need to be able to support data sovereignty. That was a core requirement. We also have an extra little tricky requirement that we need to be able to silo this data into tenancies, or what we call them workspaces. And then we need to be able to actually share certain pieces of this data between specific tenancies or workspaces. The pattern we landed on to support this is a sharded regional compute or regional data sharding, or whichever term you'd like to use to refer to it. Microsoft simply call this sharding. How this pattern works is that every region owns its own data. And so a region 1 will own data that lives in that region. And so every tenancy is assigned a region. And the data is persisted wherever that workspace or tenant, I'm just going to use the term workspace from now on, wherever that workspace lives. So in terms of actually accessing or setting this data, what a user, aka our front end, has to do, it has to use some sort of lookup service to say, I want to access data in my workspace, this workspace ID Y, whatever workspace ID it is. It has to find, okay, where is my data located? So this lookup service lets them know, I need to access the API in this region. Then, if they want to access any data, they need to contact this API, and that will then access their data in their shard. So we actually have a second layer of scale within this pattern on top of being able to split out into different APIs in different regions. We have multiple databases per region, and each database can hold multiple different shards. And so, each database is a shard, and each shard can hold multiple different workspaces within it. So what this lets us do is it lets us have any person or business or whoever that signs up can get a workspace in a region of their choice, and we can balance these workspaces between an arbitrary number of databases and then allow people to access their data by connecting directly to their region and then connecting directly to their database without having to scan through the huge amounts of transactional data that could potentially be living in this region. So, hope that was clear as mud, because Esayas is about to actually make this make sense with a demonstration. So if you'd like to take it away, Esayas.
Thank you, Ryan. Sure. Let me just share my screen. I'm hoping you can see my screen. So for this sharding pattern, we have two projects, like one solution, but two projects that we created. Like Ryan described on the slide, we have a lookup and the transaction service. Both of them are responsible in handling specific scenario. For example, the lookup service will handle any kind of configuration or figuring out where exactly our sharded like database is located. based on a region that we provide. So our controller has two endpoints. The first one is just fetch all the workspaces that we have, and the other is just create a workspace in a specific region. And this will only handle specific to the lookup, which is config, like based on the configuration we have, we will be able to create our workspace. And the second project or the second controller will be having two endpoints, this like the first one, but this one is more of data concentrated. For example, this one will be storing, of course, the same one, weather record, fetching the weather record based on the workspace ID we provide, and storing the workspace based on the workspace we provide as well. So workspace in this scenario, we can, because the workspace identifies the region, and we are technically storing into a specific region through the ID of the workspace. So let's see our database and what kind of relationship we have. So when we see our lookup service, it has a lookup service database. And the relationship, the table we have right there is like a region, a workspace, and a sharding. The region has a shard, and a shard has a workspace. Each one can have multiple, like a shard can have multiple, a region can have multiple shards, and a workspace can have multiple, a shard can have multiple workspaces. So like our tables should have multiple records configured there already. Right now, I'm not sure if you can see it. We have Australia East and Australia Southeast configured as our region, and we don't have any workspace, which we'll be creating soon. And the other one is the shard information. As you can see here, we have two shard databases, and the region, which is Australia East, is assigned to the shard 1, and Australia Southeast is assigned to shard number 2, which is ID number 5. So this is the main configuration that we need to identify the region and the sharding information. We also have database configuration, like what database we need to use, like SQL Server name, database name, and we can have multiple databases per region. And the only thing we need to notify the system is this one of them should be the primary one rather than all of them. So this is our backend database, what it looks like. Let's see the client and come back to our code and see how it works. So let's fetch our data from our, let's fetch our all workspaces that we have. It could be any region. So right now we don't have any kind of workspace. So what we can do is we can just create one. I'm creating an Australia Southeast, and the workspace is not, the workspace name is tab 2. So let's just run that. We should, yeah, we have shard, we have a workspace in shard ID 5, which is Southeast. And if we go back to our database and run this query, we should have the data right there. And do the same thing, just create one more. Let's just call it head full of heart. Instead of Southeast, let's make it East and run it. We have the second workspace. Okay, let's try a different location that we don't have. If we try that, we don't have any configuration, so that will be an invalid region. Okay, so we have 2 regions and 2 workspaces. If we pull all the workspaces that we have both of them in 2 different shards, which those 2 are located in 2 different regions. So now this means now we have a workspace located in different region, and we should be able to start storing our forecast information. So our ID is 8 and 9 for each workspace. We need to provide the workspace ID to store our weather forecast. So that one, we need to, this is get method. So let's just pull a weather forecast for that specific workspace. We don't have anything. Okay, let's just create one. Okay, we have a summary detail, temperature and date, workspace 8, and create one record. That's perfect. We have a record there. Okay, let's just make it cold, same workspace, and let's make it 10 and run it. We have two records in our first workspace. We should be able to get those two. And let's just create one more record in a different workspace, the other one, which we should not have any record. Full information, there's nothing. Go back and let's just say this is warm enough. And 20. And that should be it. Let's just run it. We have a record now, so we should be able to pull that information. So at this stage, we have two workspaces, and we have weather records in each one of them. So let's just go to the backend and like the C# code and see how this pattern is handling the requests that we just made. So the first one is fetch all workspaces. The fetch all workspaces is just simple. We can just select all from this workspace. So we should be able to retrieve that one. It's a simple query. But the second one is a different one because we have to provide a region ID, which is Australia Southeast or Australia East. If we provide that one, we should be able to get the shard information or based on the region ID. Once we confirm that our shard is not null, we can start creating our object based on the data that we received and create the workspace. That's it, simple. Now we just need to return this information to confirm that it's a success data store. And this will facilitate creating the workspace. The second one is fetching the record from the workspace. That's a little bit trickier because we need to provide a valid workspace, and that workspace needs to be available in our region or based on like in any kind of region. Without that, we won't be able to fetch that information. So let's see the code that we have. First, just to simple validate the ID is correct, and we're just gonna go and handle the sharding information based on the workspace ID that we have. Our sharding, handle the shard process is here. First, we're just capturing the IP that we get processing the information and get the shard. When we get the shard, based on the workspace, we should be able to identify that. If not, we will just return false, and that should throw an exception. But if we got the shard correct, we will be able to process that information. But we added additional validation here to make sure our IP and that shard IP URL is the same. And for this example, we used an API URL, but you can use a database or any other validation technique to make sure whoever is accessing or whatever is accessing is a proper way to fetch that data. And once we make sure that our shard is there, we just pass it to our data access layer, and that data access layer should have all the configuration that it needs, which is the workspace ID. Give me a second. Workspace information, the the workspace information, the database information, and the database server. So all this information should be available to the shard. And once we ensure that one in our workspace, we will be able to process that information and return the exact data that we need, because we have we know that the workspace ID is available. And our next post method, which is storing the weather record in a specific workspace, is literally the same thing. We just need to provide the same workspace ID, which we are passing, and handle the shard. Handling the shard, make sure the configuration is set. Once the configuration is set, we're just gonna start storing that information. That's all about how we are handling the process. This is a very simple and small example. But as a summary, I have this application, just simple Angular application that will fetch the information that we have in our system. So we have two regions, which is Australia, East and Southeast, and we have a shard that is shard number 1 and 5 for region East and Southeast. Shard database information and SQL Server names. And if we just refresh our system, we should be able to get the two workspaces that we created. And we can see that the shard ID is different than the second one, which is stored in a different place. So get that information, we have all the weather result, and get the other one, we have this result as well. So this will tell us that to load I put this button here just to show you that we need a workspace ID to pull the information. So the transaction there always needs some kind of identifier, but the lookup is just giving you a simple rough data. So that's all from me. I'll just pass it to Luca. Thank you.
Thank you very much. And thanks to everyone playing along at home. Those of you in attendance, you should have the links. It's also on the slide deck. I'm just going to bring the slide deck back up now, and we'll bring this thing home. All right. So, zoom that. All right. So, where this now starts to get really cool, if it's not already really cool, is now what we can do is we can start doing really clever things to combine all these concepts together. So what we can actually do here is we can now use command query to host the lookup information for regional sharding. So because lookup is essentially a read responsibility. It has no write apart from the occasional admin jumping in. And so what we can now do is we can actually source that lookup information and hold it in the client and then access shards directly. So we start off with our command query pattern. Then we put the regional sharding pattern beside. So now we have user and workspace information on the left, and we have secret source information on the right. And then that lookup can be migrated into the command query as one of the API endpoints, which brings the lookup information accessible from there. And so now what we've got is two APIs tuned for scale in two totally different ways, providing coordinated capabilities at scale, and then allowing magic to happen beyond the limits of what we could ever have hoped to achieve with scaling up or scaling out. So, just to summarize, what we've got are the two data sets, data that lives everywhere, heavy read, low write It's the glue that's binding our system. That's all relational. Then we've got data that lives where you want it, which is heavy read-write. Some of it's very sensitive. A lot of it has data sovereignty requirements. And so we can put your data wherever you like. Anywhere we can put a data center. Thank you, Microsoft. Thank you, Azure. We can now host your data. The bits that then aren't relational data, we can still handle in a very similar way. We can store them in blob stores, and we can serve them up in a similar way. And so if I now take a step out of our specific use case and start to say, well, who does things like this? I know they're super unpopular at the moment, but Facebook were a big early user of the command query pattern. It's why back in the day you used to see posts that you'd put up and then they would disappear for about 2 seconds before that they magically reappeared, and it's because things were replicating globally after you submitted a post. But the other one that's probably relevant to all of us being in this user group is Microsoft 365. So I'm not going to pretend I know how Azure Active Directory works under the hood, but you can. But what happens here is you've got a globalized service that is providing the glue that is binding the rest of the Microsoft 365 system together. And then you've got verticals of capability, so things like SharePoint. And what you can do then is you can use techniques like sharding to then localize and host data while still having it globally accessible from anywhere. And for those of you that used to be doing SharePoint Server back in the day, you'll remember this, right? That SharePoint had a gazillion servers, had a gazillion databases, and it implemented this really cool thing called sharding. And so these type of techniques are actually real techniques that get used in real situations to achieve these kind of global scale limits. And so I strongly encourage you to go check out the Microsoft Patterns and Practices site. It's an awesome place to summarize a lot of this stuff. You're going to find about 40 scaling patterns. So we've talked about 2 of them. There's 40 of them. So it's fun for the whole family for weeks. You're going to find CQRS, so command query, and you're going to find sharding on that site, among everything else. And then I gotta put a shout out to Uncle Bob. Go watch his Clean Code conference series. There's 6 of them. He presents to a bunch of people in Europe, and it's about 9 hours in total. Just watch a bit at a time each night, and you'll get to the end before you know it. And it's super, super enlightening and relevant to our industry. And it's not just relevant to you as a developer. It's relevant to you as a product lead. It's as an analyst, as all sorts of people. So really, really good to actually go and watch. And so before I throw to open Q&A, I'm going to just answer a few of the really obvious questions along the way. So how well does this actually work in practice? So honesty is the best policy. So in this particular system, we haven't yet actually gone live. That's not to say we haven't used these things before. Clearly, we've trained ourselves and used these techniques and evolved these practices over many, many pieces of software over a few years. So a preceding piece of software that is currently live and is currently servicing a truckload of people, which again I can't really talk about. We actually implemented both of these patterns in different ways, in different contexts, but both sharding and command query are present in that system. And what we did before we went live is we throttled the performance of the PaaS hosts down to something quite modest. We then had very limited PaaS resource in a single region. We then smashed it with requests, and we built a model of how that worked. What we then did, without scaling up or out, just scaling across, we then started cloning resource groups into different areas. We started sharding databases. We started doing all these things. And what we then started observing was load distributing across the software. You couldn't tell that actually it was doing anything different because it was all just working organically under the hood. And because we'd already written the code, it was about 10 lines of config. And so what you then do is just keep throwing more and more and more and more at it to the limits of what we can throw at these services. And what we actually found was that we could scale beyond the affordability limit of the client. The client was basically saying, no, stop, we can't turn on any more bits of infrastructure. Stop, we point proven. So we do know that these things can scale dramatically on PaaS software. It doesn't need to be IaaS, it doesn't need to be deep tech, highly abstract compute, and you can still get some amazing levels of scale. And so then, what's the theoretical limit of this scale as we attack this problem, right? So what we're really saying here is that you break problems down with software architectures into smaller, more manageable things and then tune those things. So what that really says is that the upper limit of this scale is going to be constrained by the smallest thing that you can decompose to that is still load sensitive at the highest level of scale up and scale out that unit can accomplish. Right. So what that means is that the better you can decompose your system, thank you, microservice architectures, but the smaller you can go, the more you can decentralize this model. And if you always use the same patterns and middleware baked into the fundamentals of your architecture, then it comes for free at that point. It's just configuration, which means you can just deploy it with pipelines, which means that you can just turn things on and off and reconfigure things on the fly, all for maybe a sprint and a half, 2 sprints worth of boilerplate, which is pretty cool, right? And so the theoretical limit of this scale is very, very high, certainly beyond anything that we could afford to turn on with any of the clients that we work with. And we do I think some reasonable stuff. So we want to throw out to Q&A. So please throw questions at us either on the channel or or just verbally. I'll start with one question. If you've got time, how do you manage releases given all the sharding in the back end? Do you update shards simultaneously or async? So I think Matt had to just drop off then, but let me attempt to answer that. So what we have are pipeline deploys. What we have is essentially a template database shell, and so as we have our primary deploy new workspace deploy shard that starts to fill up, what we can then do is we can actually trigger a process to deploy a new shard through pipeline. What we can then do from that is we can, in an atomic action, turn the old primary off and the new primary on, and then all of the new registrations on the platform start to go there. When you go to upgrade those things, it's just a matter of pipeline deploying the updates to each and every cell in your environment. Now that is kind of tricky because if you have to have those database shards in sync, then things get tricky. But what's really nice about tenancies and workspaces and sharding is that you can upgrade them independently as components, which means that I can go and upgrade shard 1 in Australia, leave the other ones at a different version, and as long as the interface between the data layer and the API layer is persistent, it's okay. Or I can upgrade all of the shards in that region, and then that API will service it. Meanwhile, over in the US, I can be running on a slightly earlier version of the code. So we can actually do an awful lot with pipelines when you actually automate that stuff, and that's probably for another talk, another time. And do I think that the boffins at the ABS know about this sort of scaling? I like to think yes, and I like to hope that that procurement and commercial optimizations of vendors actually get in the way, but actually deep down, we all know what the right answer is to go well. It's just that sometimes the money boffins get in the way of the delivery boffins and things go wrong. But all the best to the ABS for the next census. I hope it's going to be a cracker. Any other questions?
Luke, we had an earlier question from Paul about App Insights, as whether that's a useful tool to monitor about when you want to scale.
Yes, most definitely. So what you do is we attach App Insights to all of our PaaS services. That feeds data into the centralized log, which funny story, accumulates data really, really quickly when you get a bug in your heartbeat. But as we learned the hard way. But yes. Then what you can do is you can start to look at certain metrics on the performance of each individual moving part of your system. You also find that that if you're on top of things and you're apportioning data as you go, you can kind of build a bit of an instinct for it as well. Which basically means that you can say, oh, look, we know that this type of workload will handle about 100 of these units per thing, and so you can actually use quite simple metrics when you're talking about things that are happening on bulk. But yes, we do use App Insights, and all the monitoring comes off the back of it. Is API a monolith app? No. So I think it's a middle app. So you got a microservice which will do one thing really, really well, but it's really hard to string them together. And then you've got one single API that does everything. In our solution, we've got a total of 6 APIs that we're building out that do different things, plus an asynchronous jobs layer. That handles stuff in the backbone. So what you do is you can break a single app down into lots of little apps. So it's not microservice, it's not monolithic, it's somewhere in between, just like the 3 bears. When query serves reroutes a command to a command server, how does it know to trust that request? Ryan, do you want to try that one?
Yeah, sure. So for our application, we use for ultimately determining whether a user is allowed to make a given request, they have a bearer token attached to that request. And so when we forward our request, we also copy the bearer token header across. And so we actually copy the authorization token from the endpoint that hits query, from the request that hits query, and that same access token is then sent to command, and command validates that access token itself. And if the access token is invalid, command will say go away. But if the access token is valid and says that user with the ID cryptographically secured inside that access token has access to do this, then it'll let them do the action.
Cool.
There's also actually a second form of API. There's an admin API as well, and that's secured with an API key, which is a header, which follows exactly the same process. Our forwarding copies all the headers, and that header then gets sent to command to be validated.
Cool. Thanks, Ryan. Another one was, did we consider Cosmos DB? So the answer is yes, we did. Like with all of those sort of decisions, if I come back to the beginning of the story, we began with vision down to guiding principles. We looked at non-relational databases. What we found was that the vast bulk of what we needed to do was highly relational and actually produced highly analytical tabular data sets, and actually eventually we'll start to produce some really cool graph data sets as well. At that point, we'll probably switch to for those APIs, we'll probably switch to a graph database. For us, we didn't need a Cosmos DB because we found that for the level of the in-between stuff that we needed, we could do really, really well with JSON and SQL. And for everything else that we had, it was really, really content-y document type stuff, which actually worked just as well on blob stores surfaced with an API. Yeah. What's Ryan's microphone and how do I get one?
So it's the HyperX Quadcast S, and I got it from Amazon because JB was out of stock. It is available at JB for various different pricings.
Nice. All right. So I think we're really happy to continue answering questions, and I'm thinking that what we can probably do is continue on in an offline capacity in a sec, which will let David in the recording. But what I would like to say, as we kind of close, is and here's our LinkedIn links if you want to come and chat to us. If you do want to talk about this stuff in an offline way further, we're a really collaborative bunch. We love to chat to business people, technical people, anyone really that loves our industry, and just talk further. I also want to throw out a huge thank you to all the work that Dave does running this user group. User groups are hard work, and he does such an amazing job of this community. So a huge thank you to him. It's why we love sponsoring this event. And then the final thing I just want to say as we break is what a lot of this code is the brainchild of a lot of people that have come through our business over the years, but we consider to be peers and experts in their own right and have gone on to do other things. And each and every one of them is a part of the tapestry of what we showed you today. And I can't name them all, but they all know who they are, and they should all be really, really proud. And we're really thankful for having opportunities to work with people like that. Large chunks of this code are our own brainchild of the people in the room today, but a lot of it is augmented, like everything else, and evolved from earlier iterations and earlier attempts. So then the last bit of that is that these kind of communities and these kind of talks are really important. That what we do is we get to teach people that are in the next generation, and without that, there'll be no one else to teach the people after them. And so it's our job to kind of do this sort of stuff from time to time. So I'd really encourage all of you to activate and offer up your time to give these sorts of talks. And what you'll find is that when you help people grow, that people 6 years ago that would have been just coming out of uni turn into people like Ryan, like Esayas, like so many of the people in this forum today. And so we need to invest in our young people and grow them to the point where they're talking about cool stuff like this. So thank you so much for tonight. We'll hang back and we'll keep answering questions. We can probably turn mics on and just start chatting if you like, but we can turn the recording off at this point. Thank you.